G'day everyone, how are you going? Bit of a summary video here on arithmetic sequence and series, and then over this right hand side I've got geometric sequence and series as well. So it's just a bit of a recap video. We did a previous video on both of these in detail, all the things about it. This is really just that summary video before you go to your test, just to pick up any last little things. So when we're talking about arithmetic, or AP, arithmetic progression, what we're talking about first up is our terms. Now our terms are the individual values. Okay, so maybe a sequence goes 10, 8, 6, 4. It's the values that we're talking about, the 10, the 8, the 6, the 4. That's our terms. Now there's two ways we can describe a sequence like that. One is in a recursive definition and one's in a non-recursive. Now remember, the recursive means in reference to the term before. Okay, so we need to know term 3 to work out term 4. We need to know term 10 to work out term 11. All right? So in our recursive one, often worded in terms of t to the n. So if you get a question that says, write the formula for the following sequence in terms of t to the n, that's telling you they want a recursive formula. This is the general recursive formula for arithmetic. It's saying the next term is equal to the current one plus the difference. And remember, we've got to give a starting term. We've got to give a starting term, because just knowing that I add 3 each time or take 5 each time, well, where do I start? Do I start at 7 or 9 or 12? Where do I start? That's why we've got to give a starting term. A way to remember this that I did with my class earlier was the fact that see this, our recursive formula, as climbing a ladder. To get to the 7th step, I've got to get to the 6th, and then I've got to get to the 5th. So I've got to start at the bottom and go step by step. Whereas our non-recursive is like being in an elevator. I can walk in at any floor, press any button, and go straight there. I don't need to go floor by floor. So recursive definition, generally they're going to be 2 marks. 1 mark for this part, 1 mark for the starting term. Usually written, give a formula in terms of n. In terms of t to the n. With our non-recursive, 2 ways they'll ask. They'll say in terms of n, or they'll say a general equation. By saying a general equation, what they're meaning is, give me an equation that I don't have to work anything out, I can just jump straight to the term that I want. So that's that kind of elevator idea. I can step in at any level and I can step out at any level. This is our formula here, which we built in a previous video. T to the n equals a plus n minus 1 times d. Now this n minus 1, remember, that's really telling you how many jumps you need to make from the first term to the term that you want. So if you want to make 7 jumps, you're actually going from t1 to t8. Okay, 8 minus 1 would be 7. So that's what the idea is here, the number of jumps between the term that you're starting at and the term that you want. Now I haven't done this last video yet on on series, but series is when we add everything up. So I'm going to do another video that will show you how we build this formula together, but for the moment, preparation for the test, remember that series is adding all the terms up, and for our arithmetic, that's our formula there. So it's a bit complicated, but once we do the video on building that together, you'll see where it comes from and it won't be a great issue. That's our arithmetic sequence and series. So let's move our attention over to geometric now, and I've set the board up in a very, very similar way. Geometric terms or geometric series, we've got a recursive and a non-recursive format. Now in the same way, from back over here, remember that recursive is generally said, find me a formula in terms of Tn. And a non-recursive will say, find me a formula in terms of n, or a general formula for it. Recursive, non-recursive, very similar to just back there. Here are our formulas, and they're very, very similar in the fact that our recursive one needs a starting term, our non-recursive one doesn't. All right? Now you've seen those formulas and we've built those formulas, so there's not a big issue around them, just a matter of picking the right one at the right time. Series is talking about adding them up, and again, this formula I'll do in a video later which will show us where we get all that from. Now there's a little quirk that goes on with series for a geometric progression, and that's when R is in this range of 0 to 1. So if R is somewhere between 0 and 1, then what that means is that the value of the terms is constantly getting smaller. Let's use a nice easy one. Let's say R is 0.5. If R is 0.5, then that means that every term is half of the previous term. So that means they're going to be getting smaller, and they'll get closer and closer to 0, but they'll never get to 0. They can't get to 0, because if you halve something, you're still left with something. You never get nothing. So halving every term, it'll get smaller and smaller, but never 0. So what we find is that this term right here, this r to the power of n term, this will approach 0. It will never get there, but it will approach 0, because a half raised to some large value of n will be a really, really small term. So what we say is that this term we effectively forget about. The r to the power n, it's so small when we're looking at large values of n, we really don't care about it. So then we're left with just a on the top line and 1 minus r on the bottom line, and we write that formula like this. Sum to infinity is a over 1 minus r, meaning that I now don't need to care about the n term, the number of terms I'm summing. I just need a and r, and I can find what value the sum is going to approach. Now remember, it never gets there. So if the answer here comes up to be, I don't know, 20, it doesn't ever get to 20. It'll get to 19.999999 and continually racking up the nines, but it will never get to 20. So that's just a slight change on our series formula for geometric sequences, but it only works within this range. Outside of that range, on the greater than 1, well, our terms are constantly getting bigger, so that won't work. And on the other side, in the negatives, then our terms will be flipping from positive to negative each time, and we can't really sum that up. It doesn't work in the same way. Hopefully this has helped. This is our geometric stuff. This is all good over here. Our arithmetic over there. Hopefully that's a good little summary for you. If you need more videos or you need something explained, let me know. See you later.